Alright, so let's say given this situation here where we have a particle moving at an initial speed of 5 meters per second and a later speed of 6 meters per second, and the question asks you, find the impulse of the net external force applied on the object. To start, what is impulse? We know previously that P is equal to mv, where P is momentum. And from Newton's second law, we know that the summation of force is equal to the change in momentum divided by change in time, where summation F is the summation of net external force on the object, P is momentum, and T is time. Now, let's consider a particle is acted upon by a constant net external force from a time 1 to time 2. We could define J equal to the summation of force times this change in time, where J is the impulse, and the SI units for this is Newton's seconds, or kilograms times meters per second. Summation F is the summation of force assumed constant in this equation, and then T1 is time 1, and T2 is a later time 2. If the net external force is constant, the change in momentum over change in time is also constant. In general, the summation of force is equal to the change in momentum over change in time. So when it's constant, we can write the summation of force equal to P2 minus P1 over T2 minus T1, where this is the change in momentum, and then this is the change in time. And through multiplying both sides by T2 minus T1, we can arrive at this expression here, which on the left-hand side here is equivalent to our J definition, since our J definition is equal to this. And so if we plug in our new expression for the summation of force times T2 minus T1, we can arrive at this. This is the impulse as a function of momentum. When the net external force is constant, impulse is equal to the change in momentum from P1 to P2. Note, when net external force is not constant, it can be found using this equation here, where the summation F is the non-constant external force, and T1 to T2 is our time interval. Applies to our example. We know the impulse is equal to P2 minus P1 when the net external force is constant, and in this situation, we're going to assume that this is true. And if we assume that mass is equal to 2 kilograms, we need to find P2 and P1. So we can do this using the momentum equation given by this. So we can start by finding the momentum at point 2 by identifying that the mass is 2 kilograms and the velocity at point 2 is equal to 6 meters per second. So if we plug both these values in, we get the momentum at point 2 equal to 12 kilograms times meters per second to the right. Momentum at point 1, we can identify that the mass is still 2 kilograms, but the initial velocity is equal to 5 meters per second to the right. And so we can plug both these in. If we do a simple multiplication, we can find the answer for the initial momentum equal to this. If we plug both these values into the equation, we can find the final result for the impulse. And so this is the impulse of the net external force on a particle. From point 1 to point 2, the initial momentum is 10 kilograms per meter second, and then the final momentum is 12 kilograms times meters per second. From these 2 points, the impulse is equal to 2 kilograms times meters per second. J is positive, and this makes sense since momentum increases and the impulse measures the change in momentum. In conclusion, impulse measures 2 things. First, in terms of momentum, it measures the change in momentum of a particle. It can also be measured in terms of force, given by this equation. Impulse also measures how effectively a force being applied alters motion. So this equation measures how much force is applied and for how long this force is applied.